So I'm just trying, now after we have muddled the water enough, can somebody describe what is the difference, what is the basic difference between regular linear equation and inequality?
Inequalities have signs, for example, greater than, less than, greater to equal, greater equal than, and less than equal than.
Okay. Oh.
An inequality has greater than, less than, or equal to signs, or greater than or less than signs, but an equation has an equal sign.
Okay. Any other thought? Mr. Yep, Suchit. Yeah, Kian, go ahead.
An inequality, basically it tells you that, for example, x plus y equals something greater than 5 or something less than 5, rather than just 4. Rather
Okay.
than,
Wait.
and if you got an equals,
Just 1 second, brother.
you
Just 1 second, brother.
Okay.
Just 1 second, brother. Just 1 second. Don't run till the car stops. Okay. Yeah. Now you can go. Just let daddy stop first. Okay.
Oh, he's right here.
Okay. Then you go carefully with it. Okay. All right. Yes, Manas, you're saying something? Your head is hurting because of me?
Oh.
Okay. So I take pride in that. My job is to make sure that I make everybody's head hurt. That is when I feel accomplished. No, I'm just kidding. My job is to see if I can help you guys stay away from this brain or from ibuprofen. Okay. Now, everybody told me this. Shh, guys, no friends in the class. Everybody with the teacher only. Here. So, inequality, as you guys rightly said, inequality is something which is not equal to. Meaning, if I'm talking about this equation equal to 8 versus this equation greater than equal to 8 or less than equal to 8 or greater than 8 or less than 8, this belongs to one family of equations which is also called equality, and this belongs to the family which says inequality. And what we say, basically when you are not equal, when you are only equal, equality, when you are not only equal, that is inequality. So you have equal to sign here, greater than or equal to, less than or equal to. So you have equal to, a part of equal to here as well. But this is not only equal, so this is inequality. So basically when you talk about inequality, you can essentially come across 4 different scenarios. Yeah? And like you guys explained, and this is not the agenda for today's class, okay? So I'm not going to drag this any further. But I just wanted to make sure that everybody is on the same page. If I'm looking at this equation, we saw that we can create a table out of it with x and y values, and it will draw a straight line. It's a linear equation. So each and every point of the line satisfies this condition. So this equation only represents this line. Points falling on this line. That's what this equation represents. But when I'm talking about inequality, I'm not talking about a line, I'm talking about a region. I might be talking about the entire region here, including the line or excluding the line, depending on what kind of equality you're dealing with. Am I making sense? Yeah? So inequality represents a region. It is as simple as that. If I say x equal to 2 versus x is greater than 2, what is the broad range I'm talking about?
The region.
It's a huge, x equal to 2 is only one answer. If greater than 2, it just left to your imagination. You can start from 2.01 and go all the way till 2 trillion. It cannot fall on one line. It is a big, huge region. That is what we have to be careful about. That would be our interpretation. Suchit, are you with me, beta? Sidhu? Aditri, Adya, Manas, Om, yeah.
Yeah.
Yep, please go ahead.
Yeah.
Okay. Saying something?
Huh?
Saying something? Huh, okay. So, now other thing, small takeaway from what we learned. We'll have to always look at this like peeling of the onions, one by one. Let's say I'm talking about two scenarios of inequality. I'm talking about, let's say, x plus y is greater than 5 versus x plus y is greater than or equal to 5. No, Naita,
There's a difference.
there's a difference.
Because it's equal to unless just not
Because
equal to.
No, that is a very basic definition. I'm talking about interpretation right now.
Because
Oh, because on the
It-
quarter
it can-
plane it could be like the different region.
it can be either equal to 5, it can be 5, or less than 5. But the top one can only be less than 5.
So right now I'm talking about the visual side of it. And let's look at it. When I'm talking about x plus y greater than 5, I am not counting this line, whether my region is this one or this one. Let's assume that I'm talking about the region above this. So when I'm talking about x plus y greater than 5, I'm talking about everything but the line. I'm not including that line. Because this line represents x plus y equal to 5. Okay? So when I'm having x plus y greater than or equal to 5, then I'm including this line also. So that is the main difference. When you're talking about greater than versus greater than or equal to. When you're talking about greater than and you're talking about this region, you're only talking about that region excluding this line. Your line will become dotted. You're saying that this line is not included. This is just my reference frame. Yeah? When you're saying equal to also included, you are taking the line also along with it. That's the main difference. Yep. And Anahita, are you a computer? I think you were not in the last class. Or you were there?
Yeah, I was correct.
Okay. Alright. So everybody is clear about the equality part. I'm not going deeper into it. Yeah? Manis is clapping so many times. Don't do that. It's okay. I am not a politician who is waiting for the clap coming from all the audience. I'm a poor. Okay.
I was checking from where it's coming from. Turns out it's coming from my space bar.
That's okay, brother. That's perfectly fine. Let's not worry about it. Okay. So now let's go to the next topic that we wanted to start with. And this unit is called similarity. What do you mean by similarity?
That they are same but not the exact same.
They are same but not the exact same. It's like I'm Biren but I'm not Biren. What does it mean?
No, like it means like imagine you have a triangle.
Uh-huh.
And then the triangle is flipped
It's
over.
totally
It's the
different.
exact same thing.
But that is not similar. That is same. If see, look at me as that shape. Yeah.
It's like
One by one. I'll have to make sure that everybody gets the opportunity to talk.
there's a triangle, there's two triangles. One is smaller, one is bigger, but they have the same angles. They're
Okay.
similar, but they're not the same.
Exactly.
It's like it has like the same like common properties. Like
It has the
it's like
same
you said, like,
dimensions.
yeah, like angles and like all
It
that
has the
stuff.
same dimensions, but has different
Okay.
size, color.
Okay, color I will probably keep it aside for now.
Yeah, colors. Not
Okay, let's go to Anahita also. Yes, Anahita, tell me, what is your understanding of similarity?
Yeah, you can put it different size, but the same angles, and it's the same type of traffic.
Okay, let's see what Kian wants to add.
I wanted to say, sir, that basically, similar triangles have the same ratio. It's just scaled down.
Okay, Sidhu?
So I was in the bathroom, so what you said that when we do triangles or something.
No, we are talking about similarity. That is where we'll talk about similarity of shapes, corresponding sides, scaling up or scaling down of any shape, and then scale factor, and then we'll talk about How do you do scale drawing?
So like with the shapes.
Yeah.
I have a question. So yesterday in class, I asked you if we could do like one problem on like graphing inequalities on number line. So can we do like one hard problem? Can you like give us
One problem. Okay, so I'll come to that. Okay, that's fine. So let's do one thing. Similarity, I can still do the next class or whatever time we'll have after doing this particular problem. Is everybody okay if we do one problem on inequality time on the number line? Is that okay with everybody? Everybody okay?
Wait.
Yeah. Everybody okay? So yeah, Sidhu, tell me what the question is.
I mean, it's not like a question. It's not like a specific question. I just want.
You give me an example, okay? I don't have a question ready with me. You give me a question on the fly and I'll do it. Yes.
So like you I think last week or on Tuesday, I don't know when, but I asked you like if we're gonna do like problems. Like imagine you have like the question you wrote up. Like you're gonna like find out the value of the x or something. I forgot.
Yeah. So that is solving system of equations. That will do. Don't worry about it. We'll come back to this. Okay. So yeah, Sidhu, tell me what the question is. Give me one sample question.
16 minus 5 plus 3 minus 3.
16 plus 5. 16 minus 5 plus 3.
Yeah.
Then?
Minus 2.
Okay.
Plus 1.
Okay.
Plus x.
Okay.
Is greater than negative 1.
Okay. And what does the question say?
I just want, it's just asking to graph it on like a number line.
Okay. So this is your number
When
line.
I said 1 plus x, I meant like 1x. Like 1
It's,
times x.
it's x you're saying.
Yeah.
Okay. You're saying draw this on number line.
Yeah.
Okay.
Or wait, sorry, sir, it says 2x. Like,
Okay. Now there are two ways of doing it. One is solve this whole thing, put all the numbers together and find it out, and then solve it like an equation. That is one. Or do it using this formula. So this is a number line. Okay. What I will do is I will put, since we are talking about 16, I will use 4, 8, 12, 16, 20. Okay. Now what we are going to do is we are just going to go through this flow. Starting with 16. So I am starting from this point. Okay. This is my starting point. Are you guys with me so far? And if anybody knows anything better than this, let me know. Okay. I have not come across this problem. I'm just using common sense for going to solve this. Okay. Now this is my number line. I have 16 here. I have minus 4 here, minus 8, minus 12, minus 16. I'm starting from 16. 16 minus 5. When I'm talking about plus, I'm moving to the right. When I'm talking about minus, I'm moving to the left. So I'm moving minus 5. And everything here is split into 4, right? 12 to 16. When I'm moving 5, I'm going 5 places. So from 12, I went all the way till 11. This is minus 5. Okay? Sidhu, is that okay so far? Sidhu gave a question to the teacher to...
So you said from 16 we move minus 5, which means 11.
Yeah, so I'm just moving 5 points. It's my number line. I move by 5 points. Yeah. Now it says plus 3. So I'll move 3 points. So 11 to 12, 12 to 13, 13 to 14. I come to 14. This is plus 3. Okay. minus 2x, minus 2. So I'm again moving 2 points back. 14 to 12. I came all the way to 12 again. Minus 2.
Okay. So you're just gonna use those to like
Okay.
make way.
Right. And then 2 times x is equal to minus 1. So plus 2 times x gives me a value greater than minus 1. So let's pick up a value greater than minus 1. Let's pick up 0 at this point. Okay.
Okay.
So from 12, between 12 and 0, what is my distance? 12 points. And this 2x is greater than minus 1. This 2x. Okay? So after doing all that, plus 2x. Sorry. Yeah. So from this I'm adding plus 2x. Okay? What am I doing? Or let me do one thing. Or let me move everything to the other side. 2x is greater than minus 1, minus 16, minus becomes plus, plus becomes plus 3 becomes minus 3, minus 2 becomes plus 2. So I move everything to other side. So now we are saying 2x is greater than this whole thing. I think this will be easier. Okay. So now let's look at it from here. I think I was going the wrong direction. Okay. This will be much simpler. Okay. So 2x is greater than this value. I moved everything to one side and I kept only 2x on one side. Now I'm starting from 0. Okay. So starting from minus 1. This is minus 1. Minus 16. So I'm going 16 points backward. So from minus 1 I'm going to minus 17. This is minus 17. Then plus 5. So I'm going 5 points positive. So I'll go to 12. What is the question, Manas? So one thing, let me tell you everybody one thing. If you guys are thinking that I'm reading chat messages right now, that is not correct. So nobody will type. You have to raise your hand. If you raise your hand like this, I will be notified. Don't assume me reading the text message. Tell me what is the question here.
Isn't like it flipping? Like, because you said the negative 2 turns into a positive 2, or like it's just a normal 2?
I'm following basic concept here, which says this is your boundary line. It could be equal to, it could be greater than, it could be less than, whatever it is. If I'm making anything travel across this, my plus becomes minus, minus becomes plus, multiplication becomes division, division becomes multiplication. And that applies both ways. If you're moving any negative from here to here, it will become positive. If you're moving any positive from here to here, it will become negative. Okay? So I have not done anything fancy here. What I'm saying is, when I started looking at this, you guys saw me fumbling with this. I was going wrong. Because I was trying to do everything in one way, and then the unknown I was trying to deal with. Instead of doing that, what I'm doing is I'm keeping one type of term, the like terms on one side, and everything else on the other side. So I moved everything that is not x, meaning all constants, to other side. I could have added them all and then done the calculation, but that would have defeated the whole purpose. Because Siddhi was saying that, can you show this on number line? Right, Siddhu? So I'm not trying to kill the calculation and then give you an easier answer. That is not the whole purpose. So whatever I had, I kept only 2x on one side, everything else I moved to the other side. So when I'm moving, look at this. I'm keeping 2x on this side. 16 goes to that side. There is nothing but plus 16. That became minus 16. So I had a minus 1 and I moved this become minus 16. Plus 5 became, minus 5 became plus 5. Plus 3 became minus 3. Minus 2 became plus 2. Yeah? Does it make sense or no? Yes, it do.
So 16 minus 5 plus negative 3 plus negative 2, right?
So I'm not I'm not trying to put any intelligence for calculating it. I'm just going to rely on the number line. That's the whole idea.
No, what I'm trying to say is that makes a question.
This was the question.
Oh,
I kept 2x on one side and move everything to the other side. Yes, Sidhu, you're saying something.
so you basically like flip the sides.
Yeah.
All of the sides and put them on the other side.
Actually, I did not flip the sign. I just kept 2x on one side, everything else to the other side.
Yeah, I mean, that's what I meant. That was like the first step. I meant
Yeah.
flip the sides because
Yeah.
switching.
Yeah. So now the whole thing will be much easier. I'm talking about minus 1 first. So this is my starting point. And then minus 16. When I'm talking minus 16, I'm moving 16 places on the left. So from minus 1, I went all the way till minus 17. Then I'm adding 5 points. So I'm moving 5 points on the right side, on the positive side. So minus 17 went to minus 12. Now again minus 3. So I'm going in this direction by 3 points. So minus 12, it went to minus 15. Plus 2. So I'm going 2 points this side. Minus 13, 15 by 2 positive points goes to minus 13. Now what does it say? 2x is greater than minus 13. 2x is greater than minus 13. Okay? So I'm talking about any point which is beyond this. Okay? So 2x is greater than minus 13. So whatever be the value of x, that is, if this is, let's say 2x is greater than minus 13. So if I'm taking this as a, let's assume that 2x equal to minus 13. I'm talking about x equal to half of this distance, which will be minus 6.5. Yeah?
Mm-hmm.
So that means I'm talking about all the points, all the x values beyond minus 6.5, excluding this line. Excluding this, everything else on the number line is representing this equation. Does it make sense, Sidhu, or it doesn't?
Yeah, it makes sense, sir. I understand how you did it.
Yeah. So if I did something wrong, I would not be surprised because I've not dealt with the problem like this. What I did here was, number line helps us navigate or helps us relate the addition subtraction concepts. Okay? You can use number line for doing addition subtraction that you guys would have done a few years ago.
Yeah, because I asked you because we have like a test.
Yeah.
On it tomorrow.
Right.
Yeah, we have it tomorrow.
Right. So what I'm doing is, I'm just taking this equation and relating this on the number line. That okay, fine. 2x is landing where? If I put all the numbers starting from minus 1, minus 16, plus 5, where do I land? I landed at minus 13. So 2x is greater than minus 13. So this, everything here, all these things are less than minus 13. Any x value here will deny this condition. So you're talking about any and every point that is beyond this line of x equal to 6.5, because you got 2x equal to minus 13, so x will be equal to 6.5. So from any point above beyond this on the right hand side is what this is satisfying. I mean signifying right now. Does that make sense or it's kind of confusing? Om is thinking. What is
Makes
that?
sense.
Makes sense. Adya, Aditri, Nahita, everybody okay?
Yeah, it makes sense.
Can I go back to what we were doing?
The similarity.
I'm sorry, Rita?
Makes sense.
Okay.
I have another question that I don't have a question, I just want to clarify something.
Okay, go ahead.
So there was this question, it was also simplified number line. So there was this question where, so hey, in school we had to do like a process where, say it was like 12 plus 2x is greater than negative 1, right? Just like the same, that was the situation. You minus 12 from both sides, which gets you 2x is greater than negative 13, and then you divide both sides by 2, getting x alone,
Yeah.
and making it greater than negative 6.5, like
Yeah.
the last question.
Yeah.
It's basically the same thing, but our teacher told us that when you divide by a negative or multiply, you flip the sign, right? And when x is on the right side, you gotta flip it again to put it on the left. So if you had a problem that contains both, would you flip it at all?
So, see again, there are different ways people memorize things. For me, it is basic concept. Now look at this. If I have this thing, people will say, I'm saying that when I'm moving this guy to this side, it plus becomes minus. What your teacher is saying, okay, I subtract minus 12 from both the sides so that I can nullify this. I subtracted here, I subtracted. Same thing I'm doing. I'm just moving this guy. Instead of making it look heavier, I'm making it lighter. Okay? That is one thing. So by doing this or by whatever I was saying, ultimately you are coming to a point like this. So 2x is greater than minus 13. That means x is greater than minus 6.5. 13 by 2, 6.5. Yeah? Now, how do I relate this? If I have a number line,
Sir, what I was trying to say is like, what if the 2x was negative?
if 2x is negative, let's say if this is minus 2x. Minus 2x, okay? Okay? If this is the case. Yeah? Yeah? Like this. See, if it's greater than, make it negative, it's less than, make it positive. Don't get into that trap. Look at this like simple math. If minus 2x is minus 13, okay? Now, what does it mean to me? I can say this is minus 1 into 2x is greater than minus 1 into 13, correct? Yeah?
Yeah.
Or I will say 2x is greater than minus 1 into 13 by minus 1. I'm moving this guy. I'm not trying to memorize anything. If it's minus, I'll reverse the sign or anything. Okay? Now I can do tic-tac to minus 1 here. My 2x is greater than 13. Or x is greater than 6.5. Now whether you do it by different technique or you memorize it, I don't mind. But to me it's simple math. Yeah?
Okay.
So here, let's say your teacher said minus becomes positive, positive becomes negative, greater than becomes less than. You might miss one important sentence and then you'll end up scrambling. Oh, what did my teacher say? I forgot. Don't rely on that. Go with your natural instinct of basic calculation techniques. That's
Yeah,
it.
I have to do that, but we had to show our work in the example, so it's like hard to remember.
Yeah, so
I just wanted to calculate in my mind, but my teacher is like, even if you know it, you have to do it, or otherwise,
yeah.
you
So
can't do the easy stuff, you can do the hard stuff. That's what she said.
right. No, I'm saying, see, if the teacher needs a certain way to explain it, you can explain the same way, but when you are doing the calculation for yourself, you will be very clear in your mind. What you will write, that will depend on what your teacher wants to say. Okay? Yeah? Okay.
Yeah, I was just wondering, like, if there's like two sides, do you like flip it or do you don't? Like, if there's like x on the right side and there's like,
That will get a very clear view when you put it on the number line. It will be very clear. Yeah? Okay. So we started talking about similarity and we had a little bit of diversion. And that is okay. and that is an option for everybody. Okay, like
I'm sorry
what?
for disturbing that.
No, you're just fine. So that gives an option to everybody. So everybody in the class, if you guys have any test coming up, something, a topic that is, wait, not today. I'm saying if you have any test coming up, something that is bothering you, you pick up one question, you can ask to clarify that. If it takes 15 minutes, that doesn't hurt us. We can still learn for 45 minutes for the class, but when you have something, use this opportunity. That's what I'm saying. Okay? But you have a question? What was the question for? Yeah. So if you're prepared, wonderful. If not, we'll be fine. But yeah, never hesitate to ask if there's something that is bothering you guys.
Our school has a test tomorrow. Our school at Main Gate have a test tomorrow.
Okay. Yes, nice.
Test tomorrow. There's
The EA test for to skip 6th grade maths is coming up. So like, we're teaching the middle school curriculum for that.
What is that, better?
The EA test is basically a test to skip 6th grade math and go straight to 7th grade. Yeah, I'm taking that test too.
Wonderful.
Yeah, we just studied for it.
So tell me what. See, I would not know what all is going to come in that test. So you have to keep on picking up a topic and send it to me, because this group is for 6th to 8th grade. So I'm going to teach you guys all the concepts from 6th to 8th grade. If somebody has some test coming up in between, give me a week's notice. Say, okay, can you teach these things this week? And that will be beneficial for everybody in the class. That's okay.
Can I close the garage? It's not like a big platform.
Yes, please. Yeah. Marco, can you? Yeah. Thank you.
Unwanted students.
So, anyways, let's talk one. Now, yes, neither.
So sir, for the test I have like the study guide, but I don't know how to do some of the problems in the study guide.
So you have to just pick up a topic and send it to me. I would not be able to cover the entire study guide. So send a couple of topics. I will plan that in some other class, on the coming class. Okay. Now let's come back here. Let's come back to what we were trying to cover. We started with similarity. And what is similarity? Now, we'll keep it short because you guys are getting too excited to talk about things and then I get distracted. So, similarity, you guys explained me something in the past. Not in the past, 30 minutes ago. If I'm talking about this triangle and this circle, and if I say these two are similar, this is a
Misconception.
serious problem. There's nothing similar here.
That's round. It doesn't have any corners. That has corners.
So these are not, so shapes can be similar if they belong to the same family. I can have one triangle and this triangle similar, or they may not be similar, but we still have a chance. I cannot have a triangle and a quadrilateral being similar. Out of question. Yeah? Yes, you do.
When you're saying like similarity, you mean like sides and angles, or
So-
like it has 3 corners, 3 sides like that.
So I will touch upon every point of it, okay? And I will let you guys participate in the discussion. But when I am explaining it, probably not every sentence of mine would expect a response from you guys. I will pause and I will let you guys ask questions. Okay? And if there is any serious doubt, I'll certainly let you talk. But allow me to put the dots together. We'll use the dots to make a line, and that will make more sense. So when I'm talking about similarity, I cannot have two shapes from different family, like the examples I gave, being similar. They have to belong to the same family. If I'm talking about triangle, it has to be a triangle. If I'm talking about quadrilateral, it has to be a quadrilateral. If I'm talking about pentagon, I'm talking about pentagon. Both the shapes have to belong to the same family. That is one thing. Now, one thing that you guys see every day, every minute, every hour, whenever you're dealing with your phone, You zoom into somebody's profile pic, zoom in, zoom out, you can see the bigger face, smaller face. That is a classic example or the most practical example of similarity.
Oh yeah.
If you have a triangle, you try zooming in, this becomes bigger.
But it's the same thing.
You try zooming out, becomes smaller. What is happening here is, between this shape and this shape, when you are zooming in, your angles remain the same. Only your sides become smaller or bigger. That is what is called scale up or scale down. When you are zooming in, you are scaling up. You are making the image bigger, the shape bigger. When you are zooming out, you are making it smaller. You are scaling it down. Every side scaled down by a certain value. Okay? So, one thing before I even go talk to Sidhu, the way I want to conclude here is, if I am talking about similarity of shapes, I am talking about two scenarios. When I am zooming in, I am scaling up. When I am zooming out, I am scaling down. Meaning, my angles are not changing, but my sides are changing in dimension depending on whether I am zooming out or zooming in. Yes, Sidhu.
So, just to clarify my doubt, isn't that like dilation? Or is dilation like...
We will talk about dilation, we will talk about geometric transformation when we come to it. And yeah, correct. So there are two types of transformation, rigid transformation and non-rigid transformation, which is called dilation. Right? I'm not talking about that right now, just to keep it light and easy for everybody. Yep?
So that, when it gets bigger, it's called scaling up? Or
Yeah.
not? I mean,
Scaling up. You're scaling up. You opened up WhatsApp and clicked on your teacher's profile pic, and you want to poke into my eyes and see how big my eyeballs are.
I would not want to do that.
So if you are doing that, you are actually zooming in.
I do that.
You are scaling up. You are making it bigger. Yeah.
And then when you're zooming it out, it's
When you are zooming out, you are squeezing it in.
but it's the same thing.
It's the same. It's just opposite.
It's just like
It's just
going
opposite.
down. It's just going like
Okay. So when you are scaling up or scaling down, you are scaling up or scaling down by certain factor. If you guys remember having seen a camera, what does camera say? Oh, this has 2x zoom. It has 5x zoom.
Because it's 10x.
what's that thing called? Going.
So that 2x or 4x or 5x that you see, this is your scaling factor. You can take a picture and scale up by 5 times. This 2x, 4x that you see in the zoom lens, that tells you what is the scale factor by which you can enlarge it. Okay? Or make it smaller. Is that making sense, everybody, or I'm just
Yeah,
blabbering?
I understand.
It makes sense.
Make sense?
Yeah.
It makes sense. Oh, yeah, can I go to the bathroom?
100% good.
I'll be back in 5 minutes.
Take 5 minutes. In 5 minutes I take bath. Okay. Alright, come quickly. So what I'm saying is, when I'm talking about scaling up or scaling down, I'm talking about zooming in or zooming out. So scale up, zoom in. Scale down, zoom out. This is a practical example here. How much you are scaling up is dependent on the scale factor. That is what is called scale factor. Are you enlarging it by 5 times? Are you enlarging it by 10 times? Or are you shrinking it by half? That is what is called your scale factor. So these are the terms that you'll come across very, very often. So that is why I'm talking about it. I'm trying to relate it with practically what we see every day. So what I will do is, before there's not much of content that I can talk about right now. What I would rather want to do is throw some problems at you guys and then enjoy.
Huh?
What do you think?
What? 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 try to solve it. You solve.
So, okay, so I will show you guys some problem here. Throw some problems at you and see how you guys are relating that with the concept of similarity, and then we'll take it from there.
For a second.
But there is one more thing that we want to talk about. That is called corresponding sites. Corresponding sites.
Is it the same thing as corresponding number?
Not always. It's somewhat similar, not the same. We are talking about similarity, so everything that we talk about will be similar, not the same. Mr. Manas, don't start your car. I heard that broom sound.
Is someone outside?
That's my wife. Okay, so here we have a triangle here, A, B, C.
A, B, C. Okay. Wait, is that the corner? Is it like the sides or is it?
Don't get emotional. Hear me completely first. Okay, so we have two triangles here, okay? I want to know if this side is, let's say, which, I'm saying these two triangles are similar, okay? This triangle and this triangle are similar. My question to you guys is, which side in this triangle is a corresponding side is corresponding to this side? Aditri is saying something. I'm sorry, Beta?
Can I answer the question?
Yes, please.
It's F and D.
Little louder, Beta.
It's the side F and D.
F and D.
F and D, this one. Okay. You guys also agree?
Yeah.
Now, I don't get convinced that easily. So, Aditri, since you took a punt at it, can you explain it why you thought so?
Because that triangle is A, B, and C triangle, but this is what right now.
So, when we talk about any corresponding side, it is always based on certain reference. Now, see, I can be very playful and I can rotate this triangle by some angle like this. And it still can get confusing. But what would not change for this shape is the angle and the side relationship. Yeah. So if I'm saying these two triangles are similar, this angle and this angle are both 90 degree. So no matter how much I'm rotating it, the side opposite to that is what will correspond to each other. If I'm talking about this side is opposite to this angle. And when I'm talking about similar triangles, these two are matching angles. So I'm always going to reference this side opposite to this angle versus the side opposite to the matching angle. That is how it will be. Yes, are there?
So are the opposites corresponding?
So, if this side and this side are corresponding or not, my reference would be the angle opposite to that. Because when I'm saying these two triangles are similar, I'm saying, okay, this angle same, this angle same, and this angle same. Now, if I'm talking about this side, that is opposite to this angle. Now I know which angle is same as this one, this angle. So I'll look at the side opposite to that always. Yeah?
Thank you.
Yeah.
Can I say how I figured out it was F and D?
Mhm.
There's only one straight line like this. And then E and D were the straight line, and B and C were the straight line. So then F is the remaining letter. So then I thought, and then this is from F and D. That's the only one that's slanted, and the other one's like a long straight line. So then I was like, it has to be F and D.
Exactly. So that is another way of looking at it. One was the angle thing. Now if somebody says these two are similar, you're seeing this is the base, this is the base. Now you are seeing this is the straight line, this is the straight line. So this and this will correspond each other. This is the slanted line. This is a slanted one. So that also works. Yes, Naita.
Sir, do you have more time left to do another question?
Yes, please.
Can you give us a question over something that we learned a little while ago? Because I might be forgetting some of the stuff you taught us.
So, which are you talking about similarity alone, or are you talking about something else?
No, like stuff you learned before, similarity.
Similarity. Okay.
Can you have a question about, let's see, those ones?
What is those?
Like the x plus z divided by.
That is on the algebraic equation. So we are not
Yes.
doing similarity right now.
I didn't get my.
No, can we do that as like a refresher? Because I kind of maybe forgot.
We can do that in the next class, Dimitra, because if I keep jumping between topics, you guys will get super confused. So she's talking about similarity. So I'll stick to similarity for today. Next class I'll come to that again. Okay. So what we can do is bring two questions. We'll solve two questions. Okay. In between. Now, so Anahita, what is that you're forgetting? You have to tell me.
I think I'm forgetting equations. The linear equations.
Linear equations. So, linear equation, there is nothing to remember. It is to solve.
Is it like linear math? I kind of forgot how to solve.
Okay, so we'll talk about that. So, linear equations, system of equations, method of substitution, method of elimination, all that we'll talk about in coming classes. Not today. Okay. So let's not switch topic. Otherwise, we'll not be able to make right progress. Okay. So we talked about what is similarity. When I'm talking about two shapes being similar, I'm talking about they having matching angles. That's the only thing. Now, my angles could be matching, but my sides don't need to match. If I had a shape like this, this shape and this shape, I'm saying these are similar shapes, okay? So what you're seeing here is this is a scaled up version of this guy. Let's say this is A, this is B. I'm saying B is a scaled up version of A. Meaning you are scaling up, you are zooming in by certain factor. Okay? Now the question here is, let me give you guys some example. Let's say this is point K. So this is not A and B, this is B. Okay? This is figure 1 and this is figure 2. It says identify the point in figure 2. So let me give it a name. Okay, this is C, D and A. It says identify the point in figure 2 that corresponds to the point K in figure 1.
Wait, identify the what?
Carefully listen to me. I'll repeat. Identify the point in figure 2. This is figure 2 in figure 1. Identify the point in figure 2 which corresponds to point K in figure 1.
Oh, okay. B.
I heard it. Yes, Kian, I heard it. I heard it.
She said it, not me.
It's point B.
Point B? Okay.
I said B.
What is your answer then?
B.
B. Okay.
I
Then,
said B.
okay. Don't rush. Yes, Sidhu.
Point B, right?
Point B. Yeah. Anahita, everybody agrees to point B. Anybody who thinks otherwise? Yes, Adya.
No, I was going to say point B.
Point B. So this is easy peasy. Okay. Now, it'll be a little bit of a stretch to think and much more of a stretch for me to draw.
Oh, I see it.
Okay? And then Okay, these two shapes are similar. Let me M Q P O N, and then this is C B A E and D.
Is that B? Oh no, is that O?
Wait, I have a question. Are they both M's? M M M M?
N. This is N.
Uh,
Okay. So I'm reading the question. Identify the side in figure 2. This is
Figure
2 and this is 2 and this is 1. Okay. Identify the side in figure 2 that corresponds to side AB in figure 1. Quietly say that. No one is able to hear.
What did you say, sir? I didn't hear you.
Okay.
Right.
This is figure 1, this is figure 2, and you can see C, B, A, E, D. This is M, Q, P, O, N. It says and this is figure 1, this is figure 2. The bigger one is 2, smaller one is 1. It says identify the side in figure 2 that corresponds to side AB.
Okay. Can I say my answer?
Yep, please go ahead.
Wait, so you said D and P?
Which one?
Wait, what was it? You said the D and P, right?
Identify the side in figure 2 that corresponds to AB in figure 1. Yep.
I think that's his.
Okay, yeah.
PQ.
Oh, wait. I can't read it. It's like P and O.
This one?
It's supposed to be like-
This one is Q. O is here.
Yeah. You said C and B, right?
AB.
A, B, E, D.
Yeah.
Wait.
Kian. Thank you. Okay. Kian, what did you get?
The corresponding one for AB is P and Q, I believe.
Okay.
It's the one right next to M. What is that one?
Q. O.
PQ.
Okay.
PQ.
PQ. Adya. I heard you guys. Adya.
P and Q.
P and Q. Everybody is clear, right? You are clear? So I was purposefully doing some time pass. These were the easy ones.
Easy peasy.
Easy ones because now you look at this one. When you are looking at, I was just primarily trying to make sure that we get that visual aspect of where you are seeing corresponding sides and how are you relating to it. It was very easy for you guys to say corresponding to AB is this one if these two are similar shapes. But there is little more method to the madness. If you are looking at this side and this side to be the same, though it's visually very easy to say, but this AB is right next to this side, which is like a base. Here also, this is right next to the side, which is the base. This side, AB, and this both side PQ, both are making 90 degree with the base. So those are the things that is helping you relate to it. Just because we are looking at simpler diagram, it might be easy to relate, but whenever you are looking at anything complex or anything that is flipped or rotated, you will have to find out the correlation with anything adjoining it and then relate to it. Okay? Yes, Om, you are saying something.
My bad. My head didn't go down for some reason.
That's okay, brother.
Raised it, okay.
Okay, so now comes the actual trick.
Trick?
We talked about a term called scale factor. Yes?
Yep.
Scale up, zoom in, scale down.
Scale factor, scale up, scale down. Now, without me teaching you guys anything, I'm asking you guys a question here.
I see it.
Bro.
This is 5
Oh, wrong one.
to 3.6. And then you have another one.
I'm confused now. What's up with that? Teachers.
This one is 4, 11.3, and this is 8.9. This is figure A and this is figure B. The question to you guys is figure B a scale copy of figure A? When you say scale copy, it could be scale up or scale down, doesn't matter.
No, sir.
Huh?
No, sir.
Okay.
Scale down.
So say scale copy of is figure B
Scale down.
a scale copy of figure A, and Kian is saying no. That was very quick, but I'm hoping that you guys have thought about, you have thought about it, Kian, okay? I'll come to you why you think so. Yes, Sidhu.
I don't think so.
You also don't think so? Okay.
Rounded probably.
No, don't explain it. Let everybody think. Yeah, your answer has to be yes or no. I'll come back to you guys to get the explanation. Yes. No?
Need to calculate. 1 second.
Okay. Anahita, Manas, Adya, Ritri, Om.
No.
No? Okay. What do you think, Adya?
No.
No? Okay. Aditri? Anahita? Okay, let me stay a little away from this. What do you guys think? Is picture B, figure B a scale copy of A?
I think so.
No? Okay. How about Suchit? Suchit has been very quiet today. What do you think?
Are we like looking at the like? Wait, can you see the question one more time?
This is B, which is 2, 5, 3.6. This is A, 4, 11.3 and 8.9. The question is B a scale copy of A or not?
No.
No. Okay. Aditri?
I think no.
No. Everybody says no. I will randomly pick one. How about you, Marco? No? You also think no? So, let me see who will explain that. No, not one person always. To give chance to everybody. Since Suchit has not talked much today, Suchit, tell me, why you think no?
Okay, so basically first I obviously just looked at the phone numbers 2 and 4 and I thought that they were right, so I moved on to the next one and I saw 5 and 11.3. So basically 2 times 2 is 4, right? So that means that they're proportional, then 5 times 2 should equal to whatever that value is, but it doesn't, so.
Okay. Yeah. Everybody agrees to that? Yeah. Yeah. Adya, Ritri, Sidhu. Everybody agrees, right?
Yeah.
So again, see, I am not going to let everybody talk, because if everybody talks and say the same thing, it doesn't add value. But my only objective here is that, do we understand what is similarity? That is first thing. Do we understand what do we mean by corresponding sides? That is second thing. Do we understand what do we mean by scale up and scale down? And how do we relate that with zoom in, zoom out thing that we see every day on the phone, on the camera, or whatever, on the TV? And then, that brings us to the end of the class. We will meet again tomorrow, not tomorrow, next class. And then, we will see what we want to learn. And what I'm thinking is, just to make this class a little more interesting, you guys have the option of bringing 2 questions. That could be anybody, okay, from any topic. One child, one question from one topic of his or her choice.
Wait, one child per question.
One child, one question, and that could be maximum of 2 kids in a class.
Huh?
Meaning, so let's say you are asking one question on, let's say, linear equation, next class. That doesn't mean next class again you can ask. It can be one child. I'm giving that option to everybody.
And then
So that,
we
so in every class I can have two questions from 2 different topics, or it could be from same topic, doesn't matter. I'm coming without preparation. Imagine my situation. If you guys ask a different question, I'll be stopped. I'll be ashamed of myself if I'm not able to solve it. Okay? But that will not be the case. Don't worry about it. I enjoy what I do. So I'm giving that option to you guys. If I get notification before time, that will help me plan better. At least I would know the other thing that I'll cover apart from my topic for the day. If nobody gives that prior information and 5 of you jump together, I will have the decision making ability to choose the 2 topics that I can. Okay, because I cannot pick all 5 topics, right? So that you guys will have to allow me, otherwise I'll not be able to manage it. Yes, Om. I'll come to you now.
So we just bring in any specific question?
Any specific question? Yep. Anything. Don't bring any question on quantum physics. I have not learned that yet. Bring something that is for this group. That will benefit you and that will benefit everybody else. Okay?
If I bring like a really hard question, is that
I don't mind.
that I'm just like curious about?
Yeah, of course. Anything related to the unit for you guys. Anything that could be relevant for you guys. If you guys bring a calculus question, nobody will make much sense out of it. So let's not do that. We'll do it as long as it benefits us. Yes.
But if pretend I got a question on Tuesday and then next week again I got a question.
That's okay. If that day there's not much of a rush, and if I can manage the time, because see, ultimately, now see this. Look at the situation. As a group, we have to continue learning. No denying that. But at the same time, I'm giving that flexibility to you guys so that if I have 2 classes per week, at least there are 3-4 questions. Let's say there's 4 questions related to 4 different topics. I can still sneak that in between. But if I only look at sneaking in the new topics, I will lose track of what I was teaching you guys. Correct? So that I'm just trying to make sure that it's a proper balance of what you guys are struggling with or what you want to learn on the fly versus what is the pattern that we are following for ourselves. Does that help everybody?
Yes.
Anahita, is that sounding okay? Kian, Om, Aditri, Adya? Yeah? So make use of that. And some days, when everybody jumps in, I might not be able to make everybody happy, but there'll be a very honest and sincere attempt from my side. Okay? Yes, Anahita.
So sir, if I was to take the CA test right now, do you think I know most of the middle school curriculum? How most of it is?
I don't know the syllabus of that matter. Okay? So once you send that to me, then that's the only way I can figure out. And then if you have any test coming up in near future, then what you have to do is you have to list down the topics where you are struggling with, and that we can prioritize in this class in next whatever time we have, if we can, right? I mean, if you say that I don't know anything and there are 20 topics and I have tests coming in 2 weeks, then you are putting me on the spot. Yeah. So you have to give me some reasonable time. Look at what you can do yourself, where you are actually needing help, and then we can do it with a balanced approach. Yeah.
The test is in April, so we have a lot of time.
So if you have tested in April, we have time. If you can list down all topics where you are finding some interesting difficulties, send it to me. That will align with our course any which way. So I'll just prioritize those topics and get everybody's alignment on that to make sure that we are learning together. Yeah. All right. With that being said, I will let you guys go. It's time for dinner. I'm super hungry right now. Okay? Alright, bye bye. Bye bye. Bye bye. Bye bye. Bye bye.